Good morning, Javians. Today we are discussed about the limits. In the previous section of the limits, we have discussed the values of limit either by sampling selected x values or by applying limit theorems that we stated without proof. So motivation of the definition of two-sided limit, the statement limit x approaching to a fx is equal to L can be interpreted informally to mean that we can make the value of fx as close as we like the real number L. To do this, consider the function f graphed in figure 1.4, like this figure. If fx is in between L, L epsilon neighborhood means L minus epsilon to L plus epsilon, and x is in between the delta neighborhood of A, means x naught or x1 is the delta neighborhood of A. Then for the value of x approaching to A graph shows that x is approaching to A from left and from right, and fx is approaching to L from downward to upward. That means if x is closer to A, fx is closer to L. That means L is the limit of fx at the point x approaching to A. Always remember that x is approaching to A, not x is equal to A. That means fx is approaching to L, not fx is equal to L. Fx is approaching to L as x approaching to A, then for any positive number epsilon, means we can find the epsilon neighborhood of fx as usual as we find delta neighborhood of A. We can find an open interval x0 x1. x0 x1 doesn't, x0 x1 means delta neighborhood of A on the x-axis that contain A and has the property that for each x in the interval, the value of fx is between L minus epsilon to L plus epsilon. So this is the delta neighborhood of A minus delta to A plus delta. In this interval, extend the same distance, some distance on the both side of A and lies inside the interval. Moreover, the condition L minus epsilon less than fx less than L plus epsilon hold for every x. Since equation 1 can be expressed as mod fx minus L is less than epsilon and the condition of x lies in the interval A minus delta to A plus delta, but x is never equal to A. Hence, x minus A mod is greater than to 0 and less than to delta. From these two equations, we can define the limit. Let fx be defined for all x in some open interval containing the number A, with the possible exceptions that fx need not to be defined. We can write it as limit x approaching to A, fx is equal to L. Or if for any given number epsilon greater than 0, we can find a delta such that fx minus L is less than epsilon if 0 less than 2 mod x minus A less than 2 delta. Using the definitions, we prove that limit x approaching to 2, 3x minus 5 is equal to 1. To do this, we must show that given any positive number epsilon, we can find a positive number delta, such that mod fx minus L less than epsilon if mod x minus A less than 2 delta. That means here A is 2 and fx is 3x minus 5 and L is equal to 1. For these type of points, we have to find the delta, value of delta. There are two things to do. First, discover the value of delta for which the statement hold, and then we must prove the statement hold for that delta. For the discovery, we begin 3x minus 6 less than epsilon if 0 less than 2 mod x minus 2 less than delta. That means if we can take common in 3 between from this, then we got mod x minus 2 less than 2 epsilon and 3 outside the mod. But x minus 2 is less than 2 epsilon by 3. Here 0 is less than 2x minus 2 less than 2 delta. That means we can use delta is equal to epsilon by 3, which complete the discovery of the proof. Now we need to prove hold for the choice of delta delta is equal to epsilon by 3, then limit x approaching to 2, 3x minus 5 is equal to 1. This example is the general form of limit proof. We assume that we given a positive number, we can try to prove that we can find a positive number delta such that fx minus L less than epsilon if 0 less than 2x minus A less than 2 delta. Carl Strauss is the mathematician which discovered about the limits. To prove that limit x approaching to 0, mod x is equal to 0. To use this or to find the limit here, A implies A positive, A implies means 0 positive, Fx implies under root x, and L implies 0. Then if under root x is domain of x, is x greater than equal to 0. So it is valid to discuss the limit as x approaching to 0 infinity, 0 positive, sorry. We must show that the given epsilon greater than 0, there exists a delta greater than 0 such that under root x minus 0 model less than epsilon. That implies if x minus 0 less than 2 delta. This implies that under root x less than 2 epsilon because under root x is a positive quantity. So this implies x is less than equal to epsilon square. For if x is less than 2 delta, then delta is equal to epsilon square implies the limit of under root x at x approaching to 0 positive is 0. The value of delta is not unique. This is the main concept of the limit. In the preparation of our next example, we know that the value of delta in definition is not unique. Once we have found the value of delta that fulfill the requirement, then any smaller positive number delta 1 will be fulfill all those conditions. It is true that mod fx minus L less than epsilon if 0 less than mod x minus A less than delta. Then it will also be true that fx minus L less than epsilon if mod x minus A less than 2 delta 1. That means if we can find a delta is equal to epsilon by 4, epsilon by 5, epsilon by 6, epsilon by 3, we all the deltas are satisfied all these values. So from here we can find that the delta is not a unique. X square is equal to 9 for x approaching to 3. That means x square minus 9 is less than epsilon whenever mod x minus 3 less than delta. This because mod x minus 3 occur in the right side if statement, then it will be helpful the factor left side to introduce a factor x minus 3. X square minus 9, we can write it as x plus 3, x minus 3 less than 2 epsilon. Then mod x plus 3, if we knew, for example, delta less than equal to 1, then we would minus 1 less than x minus 3 less than 1. This implies 5 less than equal to x plus 3 less than 2, 7. And consequently, mod x plus 3 less than 2, 7. Thus, if delta less than 2, 1, then mod x minus 3 less than 2 delta implies mod x plus 3 mod x minus 3 is less than to 7 delta. This this implies 7 delta is less than 2 epsilon. We can achieve this by taking delta to the minimum of the number 1 and epsilon by 7, which is sometimes written as minimum 1 or epsilon by 7. That can prove x square is equal to 9. This is the main proof. This is the main example for to understand that the value of delta for which or we can define delta for epsilon that this is not a unique delta. Limits as x approaching to positive or negative infinity means limit x approaching to positive infinity and limit x approaching to negative infinity. Definition: let fx be defined for all x in some infinite open interval extending in positive x direction. Extending in positive x direction means x is approaching to positive infinity. X is approaching to positive infinity, fx is equal to L. If for any number epsilon greater than 0, there correspond a positive number n such that mod fx minus L less than 2 epsilon if x is greater than 2. And similarly, if x is extending in the negative direction of x axis, then we may write as x approaching to minus infinity, fx is equal to L. Yeah. Fx we define in some open interval containing a, except that fx need not to be defined at a. Then we may write as limit x approaching to a, fx is equal to positive infinity or maybe negative infinity. Then if for any given positive number m, we can find a delta greater than to 0 such that fx satisfies fx is greater than to m. M is a very large number. For 0 less than 2x minus a less than 2 delta. That means x is approaching to infinity on that point. On that point means x is approaching to infinity on a. Similarly, if fx defined in some open interval containing a, except that fx need not to be defined on a, we will write x approaching to a, fx is equal to minus infinity. Then if m is a negative number, large negative number, we can find a delta greater than 0 such that fx satisfy fx less than 2m. If 0 less than 2x minus a less than 2 delta means इतने बड़े नेगेटिव नंबर से भी छोटा नेगेटिव नंबर हो तो हम बोलेंगे कि एफ एक्स जो है उस ए पॉइंट के ऊपर आपका माइनस इन्फिनिटी को अप्रोच कर रहा है. This do that limit x approaching to 0 1 by x square is going to positive infinity. Applying the definition fx is equal to 1 by x square and a is equal to 0. That means we must show that given a number m greater than to 0, we must find a delta. 1 by x square greater than 2m if 0 less than 2x less than 2 delta. This means x square is less than 2 1 by m and x is mod x is less than 2 1 by under root m. That means delta is equal to 1 by under root m implies limit x approaching to 0 1 by x square is equal to positive infinity. So these are the exercise for that practicing to find the limits on this from 9 to 16 all are the important, so please find and verify the limits of these questions.